this video is an introduction of the Inference Engine Arena, which I put it here. Hopefully it will become the Postman as well as the Chatbot Arena for inference benchmarking. What does that mean? It means that it consists of two parts, the Arena logging system and the Leaderboard. The logging system has engine management, which you can start, stop, list, manage different inference engines with a unified command line. You can also benchmarking with ease with predefined and custom benchmarks. It automatically collects critical metrics and stores them in a unified way so that you don't have to use the spreadsheet to store and compare them later. It also allows you to has these YAML configurable files so that you can do batch experiments with different engine arguments as well as different benchmark configurable configurations so that you can just run them with one command line. It also has a dashboard which you can visualize the results and compare them easily. The Arena Leaderboard allows you to compare different models, hardwares, workloads, and inference engine configurations with the whole community. So with that, let's go to the installation part and let me show you how it works. So here is an empty environment which contains 8 H100, which will conduct our experiments here. So first we will use this GitHub token to clone our repository and then cd into the directory and then create the virtual environment and enter it, as well as installing all the necessary packages. Alright, so after installing, we can type arena-help or just arena to see all the available commands. For example, the start, stop, list, and logs is regarding the engines. The the run and run YAML is regarding to run benchmarks, and dashboard, leaderboard, and upload. We will cover each one of them later. Let's get started with start and engine. So first, with the arena start followed by the engine name. Currently, we only support two engines, the VLM and the SGLen, and then followed by all the engine arguments or the parameters. So it will be exactly the same after VLM serve, so that there's no learning curve of it. And of course, we also support the environment variables. So let's just try it out with a small model and with some non-meaningful parameters with arena start. So as we can see here, after we type arena start, it will start streaming the logs of this engine. While it's starting, we can take a look at the SORL document of that, so that it's start and then engine type and then the model name and then followed by the engine arguments. It also supports the VLM variables for VLM and then for SGLen. Yeah, basically that's it. I will jump to the time that the engine gets started. So now that the engine has been running, it will exit the current process so that it will be running behind the scene so that this terminal won't be occupied. If we want to see the logs of this engine again, we can use arena logs followed by the engine name. For example, this one, it will print out all the latest 100 lines of the log, or we can use the -f to print out the interactive log. Other than that, we can use arena list to list out all the active engines that is running behind the scene. For example, currently we have one VLM engine which runs this model, and then here's this endpoint, and then it's only use one graphic cards out of the 8 graphic cards environment. Otherwise, it would be a times how many graphic cards it's using. Note that you can also start multiple engines at the same time. For example, you can start a SGLen at the same time. It will be useful for parallel benchmarking later. Of course, you will need to specify the CUDA visible devices. So here comes the most important part, running benchmarks. First off, we define a set of preset benchmarks. Let's take a look at them. We call it the conversational short, medium, long, and rewrite SE, write SE, and summarization. For example, rewrite SE has a very input token as well as a very long output token. in contrast, the write.se has a long output token, however, very few input tokens. Likewise, summarization has a long input token, but a relatively short output. The conversational short is 100 input token as well as the output token, and it has 0 prefix token. It was shooting at the server at the QPS of 10 in total of 50 queries. Of course, you can always define your own benchmark configurations later, or you can adjust certain parameters of them in the batch running mode. However, it's just easier for us to preset some to set up a standard to compare in the leaderboard. With that, let's take a look at the commands. So here you can see that you can run one benchmark on one inference engine, or you can run multiple benchmarks on one inference engine, or you can run multiple benchmarks on multiple engines at the same time. We can, because we only have one inference engine running, now we can try with this command. So it starts running. And then while it's running, let's take a look at the whole life cycle. So what we did just now is that we start an engine and then run 3 benchmarks on this engine. I call it manual mode because it's kind of manual because you still need to start the engine and then run the benchmarks by yourself. Actually, there's more convenient way to do that, and I call it batch mode. So we will cover that later, but in such scenarios where you need to you know your workload, which means that the benchmark configuration looks like, and then you want to test a series of engine configurations so that you don't have to actually start the engine and then run certain benchmarks on top of that and then change the configuration and then stop the engine again and then start everything over again. You can just configure them in a YAML file, and then with the run YAML mode, it will just help you out with that. We will demo that later. Or it doesn't have to be one benchmark, it can be multiple benchmarks, and then it doesn't have to be one engine. It's the run YAML mode is very, very flexible, and actually it saves me a lot of time when benchmarking. Okay, now the benchmarking has finished. We can see in the results folder, there's a run folder followed by, so actually this is the run ID, and then there's a JSON file about this run, and follow that, there's 3 sub-run folder. Each one of them is named by its sub-run ID. So regarding the run and the sub-run, it's actually very important concept in Inference Engine Arena. So a sub-run is a single benchmark run of specific engine configuration, benchmark, hardware, and model combination. It's kind of like a minimum executable benchmarking. And then the run is a group of sub-runs. So what we did just now is that we run 3 benchmarks so that it has 3 sub-runs. And then let's take a look at the run JSON file. For the run JSON file, it records the ID, the start time, the engine, benchmark types, 3 benchmarks, and then all the visible GPU devices, although we're not using all of them, and then all the sub-run IDs it correlates with, and as well as the duration. For the sub-run, it records even more comprehensive information. For example, the run ID itself, the parent run ID, the engine has the engine name, the model is running, the data type and quantization, which will be useful for later, and then the engine arguments, which is what you specified explicitly, and then the environment variables such as VLM, use v1, or torch compile, as well as the full engine arguments, which is for the majority of the engine arguments, there's default value for them, but we still need to record them for later comparison and tracking. as well as the full environment variables, which is less important than the engine arguments, but still it's necessary to record them, as well as the version information of the engine, so that you can compare Apple with Apple. And then the GPU information is only use one graphic cards. For the benchmarking part, here is the configuration that we specified. For the benchmarking, it also has some default values, and then the start end time, whether it's successful executed, as well as all the important metrics which we can derive some other metrics like dollar per million token, and then the per request latency out of these basic metrics. If there's any error or the whole log of this sub-ROM, they will be recorded here. So here comes to the data visualization part. Let's start it by using Arena Dashboard. So Arena Dashboard really is just a more user-friendly or visually friendly way to present all these data to you, so that we will see that it auto forwards the port 3001 so that we can access it with our local host. Because we only conducted one experiment, which means one runs, so that we only have one run here. And then you can see a chart which combine these three sub-runs in a summarized way. We can just compare the differences of that and then view the metrics of them. We can see that the only difference for the sub-run is the benchmark type and the configuration. However, for some scenarios, maybe you keep them the same and then you change the engine arguments, or you have different engines, or you have different environment variables. So everything can be compared with each other. For the metrics, we list out the input-output throughput, the TTFT, TPOT, as well as the per request throughput here. And then we have like a little like a data visualization like histogram, so that you can see if you hover over it, you will see the detailed value. This one is 936, and you can also see the engine arguments, the engine vars, the benchmark configuration of that, so that you can just compare with them with ease. This one is about 14,000, and then you can see the input throughput is growing because I guess because this one has just too little input to be processed, so that the engine has not reached its capacity. However, for the time to first token, the conversational long has the largest TTFT, which also makes sense. Anyway, this is just a very simple scenario. You can really customize that and do a lot of things with the data visualization. And then we can also has the option to select a certain sub-ROM. This is again just a visually friendly way of presenting that JSON file, so that it has the ID, start time model, the engine information, benchmark information, the performance metrics, as well as even the output, the arrow if it has one, the full engine arguments variables, and then the benchmark configuration, and then it will present the same chart as before. And also you can hit the refresh data to refresh it. Also, it uses the watchdog, so that whenever a new experiment has been conducted, it will automatically refresh. So the local leaderboard, as the name suggests, it only reads data from the results folder locally. It has several filters: the model, engine, benchmark, and GPU. It will auto collect all the possible options from the data points, and each data points in this table is a sub-ROM. It also has some checkboxes that you can pick. In general, this provides a more like user-friendly way to present it. However, it's still very similar to the table that we presented in the dashboard. If we click on this Show Details checkbox, it will present even more details like engine args, engine vars, the benchmark configs, as well as a reproducible commands if we want to reproduce this certain sub with Arena. It also has a advanced filter for if you want to filter only some data points with certain variables, like this one, the max num sequence is equal to 256, then you can get it. The second checkbox is called the show custom benchmarks. So by default, we only show the non-custom benchmarks, which is defined in this folder. And you can always define more by yourself. But if you want to just experiment some different QPS or different number of prefix token size, then probably this is a good way to present it without messing up the whole leaderboard. And then this one is called the show all precision. These options like int4, int fp8, fp32 is a simplified way to present the data type as well as the quantization. Otherwise, it would be just too many of them. So we have some value selected for this filter. The VLM for the engine, the rewrite ASCII for the benchmark, and then one H100 for the GPU. If we scroll down, we will see this nice chart, which is very similar to the chart that Jason Huang presented in the GTC 2025. So in this chart, it will list all the common attributes on the top and all the differences on the bottom. For example, all the data points or all the subrounds in this chart is running rewrite ASCII benchmark, is running on a single H100, is running this model and on VLM. However, every engine configuration on the blue line is on FP8 quantization method, and then BF16 for the ones on the orange line. So each data point has different engine configurations so that you can clearly compare different engine configuration performance against a certain workload. For example, this one is kind of the default one, and then this one turn on the enforce eager, this one turn on the tokenizer mode to be slow, and then this one turn on no enable prefix caching, this one use VLM v1. So that you can compare them freely. Usually, if the point is to the top right, then it will be better because these graphs illustrate the relationship between the TPS, which is the throughput per second per user, against the total throughput for the data center or the provider who hosts this model. So usually, if each user wants to have a faster generation speed, the total throughput would be kind of jeopardized. However, if you want to have a larger batch size to optimize the total throughput, then usually each user would experience a much slower generation speed on their end. And then you can also double click on one line to make it more, just show that line. And then also you can zoom in this to compare the details. For example, this one is kind of like the default one, and then this one with the tokenizer slow, and then this one with the enforce eager equals to true, and then turn it on, and then this one is no enable prefix caching, which has a slower performance, which makes sense. This one is using VLM v0, which has a slower performance, which makes sense. And then if we compare those two lines, we will see in general the performance of the blue line is better than the orange one because of course it's half the precision than the orange line. So each data point has I would say a much better performance than the points on the orange line. Of course we can set up more filters. For example, if we want to show two different inference engine under this condition, we can get that information, although it's not very intuitive, but we can see that there's one less common attribute, but one more differences, so that it has 2 times 2, which is equal to 4 combinations of that. maybe let's refer to the VLM, and then let's see the performance of all GPUs, so that we can see that if you're using 4 GPU for the tensor parallelism, then in general the performance is better with the orange line and the blue line, which is better than the green line and the red line. Actually, you can do a lot of customization here. For example, let's just say we select one GPU and then we show all benchmarks. So it's kind of the combination of the benchmark as well as the position. Yep, so in general, you can have a lot of combinations. You can have actually infinite possibilities or combinations here. So yep, hope you like it. That's all for the local leaderboard. There's another leaderboard called the global leaderboard if you click on this button. So the global leaderboard is essentially just a hosted version of the local leaderboard. Currently, it only has one data record on it. However, I will upload more and then fulfilled by the community in the next few weeks. It also has this table as well as this chart. The only difference is that it has one extra checkbox called only show results from verified resources. So if the contributor is anonymous, which means the identity is unknown to us, then it will be considered as not verified resources. I will show you how to upload and in just a minute. The source code for this global leaderboard is also open source in the repository, so feel free to check out. To upload data records to the global leaderboard, we have two ways to achieve that. The first way is to go to the dashboard and then select any sub-run, and then click this share sub-run to global leaderboard button. And then it will say the JSON uploaded successfully. If we refresh that data here, we will see that being uploaded. The other way is to, let's just terminate the dashboard and then use the terminal way. Let's use Arena dashboard, and then we start, it will automatically scan every sub-run within the results and then upload them, each one of them. The other way to run automatically is to run YAML file. You can do this by using Arena run YAML and then followed by the YAML pass. So in this YAML file, I have a few example YAML file. And then in this one, you can see that I specify some engine arguments and then followed by some benchmarks and then some other engine arguments and then followed by benchmarks and then some other ones followed by benchmarks, so that everything will happen just automatically. You don't have to start, you don't have to do anything. And then all these experiments will be conducted as expected, and then they will be combined in one run. Each one combination of a benchmark and a engine configuration will be considered as a sub-run. It saves me a lot of time. That's it all for the Inference Engine Arena. For more details, you can check out the source code or the documentation. However, it's the whole project is finished in a very hurried manner, so it's definitely not perfect at all. So if you spot any bugs, or if you would like to add any features, feel free to contribute or raise an issue. Thank you.